Welcome back to the GCSE Maths Pro YouTube channel. Today's video is going to be a summary of the whole topic of cumulative frequency. So we'll be covering how to plot a cumulative frequency graph and filling out the table. Then we'll be looking at how to find the median, upper lower quartiles and interquartile range from the graphs, and also how to find percentages or quantities from the graph as well. Finally, we will be touching a little bit on box plots at the end, as these two topics do kind of go hand in hand. So we're first going to just start off with using the cumulative frequency table. So here we have the cumulative frequency table shows some information about the weights in kilos of some dogs. Plot a cumulative frequency graph for this information. The first thing we need to understand is what is cumulative frequency. So breaking it down into the two words. First of all, frequency is how often something happens, or maybe the number of times, or in this case, we've got dogs, so the number of dogs. Okay, the amount of dogs. Cumulative means every time we're adding more, we're including more. Every single time we're going to increase and increase and increase. So the cumulative part would make more sense when we look at this left-hand column of the table. The weights, we've got obviously W refers to weight, right? So we're saying for the first row, the weight is between 0 and 5 kilos. And we're saying, well, how many dogs weigh between 0 and 5 kilos? Well, that's 8 dogs. The frequency is 8. The cumulative element comes in where, do you see how the second row still starts with 0, but now it goes up to 10 kilos? So obviously the second row is also including the first row because it's going from 0 to 5 and also then 5 to 10. It's including those first 8 dogs plus however many dogs from 5 to 10 there are. So you should see that each time your cumulative frequency table should be increasing. It will never decrease if it's cumulative. Every time we're adding more. Every time, in this case, we're including another 5 kilos. You see how here we've gone from 5 to 10, 10 to 15, 15 to 20, and so on. We're including another 5 kilos every single time. So obviously the number of dogs, or the frequency of dogs, is going to be increasing every single time. So for a cumulative frequency table, the other piece of information that's helpful is to know that the final row is obviously the whole of the weight, so 0 to 30. So you can see here as well, our graph goes from 0 to 30 kilos. And therefore, the frequency part will be the total number of dogs. In this question, it says the weights of some dogs. But actually, we should know, well, there's actually 40 dogs in total in this table. As you can see, that's why the cumulative frequency axis only goes up to 40. So that's a little introduction into actual cumulative frequency. For our graph now, what we're going to plot is obviously the cumulative frequency bit is the y-axis. That's pretty straightforward. But the x-axis being the weights looks a bit confusing. It's not going to be a bar chart or a histogram or anything like that. It is a curve. So you might be wondering, what do I plot this? We will always plot the right-hand side of the inequality. So what I mean by that is the numbers on the right-hand side. So in this case, we're going to plot at 5, at 10, 15, 20, 25, 30, and so on. We're obviously not going to plot all of them at 0 because they would all be then stuck on top of each other. We're also not going to work out a midpoint. Okay, you might have seen that before where you have to work out a midpoint. That's not for cumulative frequency, okay? The midpoint is always for frequency polygons. That sounds similar. It has the word frequency, but it's not the same topic at all. Okay, so we're not doing the midpoints. You're just literally plotting the right-hand numbers on the x-axis. So for example, our first one is going to be plotted at the coordinates 5, 8. So come 5 along and then 8 up. Obviously, always check the scale of your graph. The next one is going to be plotted at 10, 23. So 10 along, 23 up, and so on. You can kind of get the point. So the next one will be at 15 across and 28 up. The next one will be 20 across and 33 up. The next one is at 25 and 37. And then obviously the last one will be at 30, and the highest amount of dogs we've got is 40. So you can see how my graph is continually increasing. It will never drop down again. Now that we've got this, we need to draw a rough curve. So start from 0 and go just through all the points, creating a curve as best you can. Something a little bit like that. It's meant to be a curve. You're not going to join it up with straight lines. Try and make it as nice of a curve as you can. But as you can see, it is constantly increasing up until we hit the total amount of dogs, which is 40. So that is how we plot a cumulative frequency graph. Our next question is then adding in an additional step before we get to the graph, okay? So this is where you also have to pay attention to the question. Does it give you the cumulative frequency table, or does it give you just the frequency table? There is a difference here. So for this question, we've got the frequency table, so just the frequency table, shows some information about the heights in centimetres of some sunflowers. Part A is to complete the cumulative frequency table first of all. So we're going to have to convert it from just frequency into cumulative frequency. This is normally just 1 mark because it's really straightforward. But let's have a look at the differences between the tables so you can fully understand. We obviously saw in the previous example the cumulative frequency table. In this case, it doesn't start at 0, but you see how they are still starting from the same number every time. On the left side, so we've got 140 centimetres is where we're starting. And then each row adds a little bit more to the range. So we've got 140 to 150 centimetres, then 140 up to 160, then up to 170 and so on. So you can see that each time we're adding in more and more of a variety of heights. If we have a look at just the frequency table, it starts at 140 and then to 150, but then you see how the next row is completely separate. It's now starting at 150 and going to 160 and so on. So this one we're saying, okay, the frequency again is just a number, in this case the number of sunflowers. We can see there are 4 sunflowers in between 140 and 150 centimetres. Separately to that, there are 11 between 150 and 160. Again, separately to that, there are 21 sunflowers in between 160 and 170 centimetres. But then you see how it then decreases. We obviously said with our cumulative frequency table it should never decrease because every time we're including more and more. But here they're all separate categories, aren't they? So, if you have a look, the first row is the easiest because you see how the heights are exactly the same. 140 to 150. So it's saying, well, how many sunflowers are there between 140 and 150 centimetres? Well, obviously that's still 4. That first row is exactly the same range, isn't it? But then do you see how the next one is now starting at 140 still, but now we're going up to 160. So do you see how that not only includes the 140 to 150, it now also includes the 150 to 160 as well. So to work out 140 to 160, it's going to be both of those rows together. So in terms of the frequency, do you see how that would be 4 plus 11? Because that's how many sunflowers are between 140 and 160. Well, that's these 2 rows here. So this one would have to be 15. It's including this previous 4, right? Then if we look at the next one, we've got 140 to 170. So yeah, that includes the first row, that includes the second row, and now it also includes the third row. So how many have we got in total? I now need to add 4 plus 11 plus 21 as well. So there are 36. That's including the previous 15, isn't it? Do you see the pattern here? Every time we're just going to add each row additionally, cumulatively. That's what cumulative means. Every time I'm adding another row from my frequency table. Okay? So the next one, 140 to 180, obviously includes this 4th row here. So add another 15 to our 36. We get 51. Then we're going to add another 7 to get 58. And finally add another 2 to get 60. Now, this final row, as we mentioned before, is the total. So sometimes in the question they'll say how many there are, and you can make sure that matches. In this question, it just says some sunflowers. It hasn't told us, so we can't check. But 60 obviously seems like a reasonably round number, doesn't it? So sometimes you might have to do that first. That's your first mark. You just literally keep adding another row every single time. Now for the next bit, just copied that table here. So we've got the exact same thing, the cumulative frequency table. Part B is to plot a cumulative frequency graph for this information. So obviously we're just going to carry on as we did in that first question. Now that I've got the cumulative frequency table, I can then just copy across those numbers. Again, remember which of the values on the x-axis we're going to plot. It's always the values on the right-hand side of your inequalities. So the first one we're going to plot 150 across and 4 up on the y-axis. So you can see here 150 and then 4. Again, double check the scale of your graph, sometimes they change. The next one's going to be at 160 and at 15. Then we're going to have 170 and 36, and hopefully you can see the pattern now. 180 and 51, 190 at 58, and finally 200 at 60. Again, you can see this graph stops at 60, so you know that you've probably added them up correctly as well. And now just draw a curve through them all as best you can with your pencil. Okay, something roughly like that. You can see it's this increasing shape. So that would be normally about 2 marks to draw the graph. So the cumulative frequency graph shows some information about the weights in kilos of 40 dogs. They've given us the total. You can see at the top of this graph, it also comes to 40. Find the median weight. So the median means the middle, okay? That's quite straightforward. Most people know that. But then you're kind of thinking, well, the middle of what? The middle of the y-axis, the cumulative frequency, the middle of the x-axis, which is the weights. There's two things. One thing, the clue is the fact that they've asked for the median weight. Your answer will probably be a dotted line with kilos. So you know that your answer is going to have to be from the x-axis. The main thing we need to remember is the middle of what? So think about it. If you have 40 dogs lined up in front of you, imagine that they're lined up in size or weight order in this case. We want to know how much does the middle dog weigh. So let's say dog number 20. How much do they weigh? So you're always going to be looking at the cumulative frequency axis, the y-axis. Cumulative frequency, as we explained in the previous video, is a quantity. So that's why it goes up to 40, because there are 40 dogs. So what you're going to do when you're finding the median of anything from a cumulative frequency graph is go to the y-axis, or if it says in your question, check what the total is. In this case, we know it's 40 dogs. The median is the middle, which means half. So I'm just going to work out, first of all, what is half of 40? Which obviously is, in this case, 20. So dog number 20. Then grab your ruler and just draw a line across from 20. So it hits, obviously, the curve. And then go down and read off the x-axis. So we can see here, let's check, just be careful what the scale is as well of all these graphs. We've got 10 squares, but that represents 5 kilos. So each of the 2 squares is 1 kilo. That's 11, isn't it? 12, 13, 14. I would put that at 14. So the median is 14 kilos. So the middle dog, or the median weight, is 14 kilos. It's literally as simple as that, but you do have to remember half of what? It's half of the y-axis, okay? Okay, so for the next question, we've got the cumulative frequency graph shows some information about the heights in centimetres of 60 sunflowers. So again, we've got that total 60. And you can see here, the graph also goes up to 60. Find an estimate for the interquartile range of the height. Okay, so first of all, we need to remember what the interquartile range is in the first place, isn't it? So interquartile range is the upper quartile minus the lower quartile. It's a range between the 2 quartiles. That means I therefore need to work out the upper and the lower quartiles, and then I can subtract them. So the upper quartile relates again to the median. We said the median is the middle, which means halfway. The upper quartile is 3/4, or you might think of it as 75%. And again, it matches with the median. It's of the cumulative frequency of the total, in this case, sunflowers. So we want to know what is 3/4 of 60. The lower quartile is the same, but obviously being the lower one, it is just 1/4, or if you want to think about it as 25%, that's fine. So you just have to work out, let's do the lower quartile first. 1/4 of 60, so you can either do it in your calculator if it's a calculator test, or just divide it by 4, is 15. So I need to come to, in this case, imagine sunflower number 15. Draw a line across, always from the y-axis for this topic, and then down to the x-axis. About there. So that looks like it's 1 square along from 160. Check in scale, it's 1 square is just 1 centimetre, isn't it? So I would go with the lower quartile being 161 centimetres. Then for the upper quartile, do exactly the same, but obviously now not 1/4, we want 3/4. So either, again, do it in your calculator, or to find 3/4, it's just 1/4 times by 3. So 15 times by 3 in this case is 45. That's 3/4 of 60. Again, just draw a line across and then down. Okay, that I would say is 167. So the upper quartile is 167. And then the last thing, as we said, the interquartile range is obviously a range, so we're just going to subtract them. So 167 minus 161 is 6 centimeters. So the interquartile range is 6 centimeters. Again, it's in terms of the units of the x-axis, isn't it? So do you see how it's exactly the same as the median? The only difference in that sense is the median is at 50% and the upper and lower quartiles are at 25 and 75%. But the method is the same of going from the y-axis across and then down. Okay, so another example is the cumulative frequency graph shows some information about the heights in centimeters of 60 sunflowers. Find an estimate for the percentage of sunflowers that are taller than 175 centimeters. So this is a very similar question. We've been asked for, again, taller, so like more than. So it's the same scenario with the more than. And they've given us the benchmark of 175 centimeters, which again is obviously from the x-axis. So find 175. Luckily, this one is a nicer scale. And obviously, I'm going to draw my line upwards from there and then across to my y-axis. Roughly about here, I would say. So if we read that off, I would give that as 56. Now, again, remember that they're asking for taller than that. 56 is the number of sunflowers that are shorter than 175, isn't it? It's all of these sunflowers here. These are the first 56. So that is from 140 up to 175. What we want is this part of the graph where it's from 175 and then obviously taller. So that is this small part here, this small amount of sunflower plants there. So just remember, again, we're going to do 60 because that's the total number of sunflowers, minus the 56 that are shorter. That gives us 4 sunflowers. Now the difference with this one is that they've also asked for a percentage. The previous question they asked for how many, what number. In this case, they want a percentage, so I now need to take my 4 sunflowers and convert it into a percentage of all of the sunflowers. So I know it's out of 60, so when I want to make a percentage, I just take 4 out of 60, that's a fraction obviously, and then to make a percentage, times by 100. This may or may not be a calculator question. If it is, obviously chuck in your calculator. If it's not, they should choose numbers that you can reasonably work out. This one would obviously be a calculator one. I'm going to round it to 1 decimal place because it is a recurring decimal. I get 6.7%. So that's my final answer for this one. Okay, so we not only need to know how to use the graph, but also how to convert into percentages. The cumulative frequency graph shows some information about the speeds in kilometers per hour of 100 police cars on patrol. Find an estimate for the percentage of police cars that drove between speeds of 30 kilometers per hour and 70 kilometers per hour. So this one, we've actually got 2 benchmarks from the x-axis. So I'm just going to do the same thing, but draw 2 lines. So obviously 30 and then 70. So draw the line from 30 to hit your curve, and then across, and then from 70, and then across. Okay. So I'm going to find out how many cars, obviously out of 100, how many cars drove between those speeds. You can see that that's obviously referring to this part of the graph because we want between 30 and 70, and therefore this amount of the y-axis. The y-axis is the cumulative frequency. That is the amount of cars. So you can see here we've got, that's 30, isn't it? So here I would say, what's that, like 24? And then up here, that's 90. So I would say that's 97, I guess, somewhere about there. Again, you should get a small range for your answers. So we want to know how many cars drove between those 2 speeds. So we're obviously not including the first 24 cars, are we? Because they are the ones who drove slower than 30. So we need to do now 97 minus 24. That gives me 73 cars, 73 police cars. And then the other thing to remember is that they have asked for a percentage again. So this one's a bit easier. Obviously, this might be a non-calculator one. 73 out of 100, you don't even really need to write it down because you can probably see what the percentage will be, times 100 is obviously just 73%. So 73% is my final answer. So, having watched these 2 videos, the previous one on median and interquartile ranges, I want you to be really confident on when do I draw, or when do I work from the x-axis and go up and across. So in this scenario, when they ask for numbers or percentages, when they give you values from the x-axis, or when we start working from the y-axis and go across and down, that's when we're asked for the median, the interquartile range, or the upper or the lower quartile. So there's 2 different types of Part B, Part C questions that you could get given. They're very similar, but they work in opposite directions. So just be really, really clear which one is which, okay? So box plots are drawn on this kind of horizontal graph paper. We just need to memorize what they look like and what components they are made of. So which parts are they made up of? So for example here, the table shows some information about the weights in kilos of some dogs. Draw a box plot for this information. What you need to know is that we need 5 vertical lines. So one obviously for each of these parts here. You'll need one at a minimum. They might say minimum, or they might say lowest, or they might say shortest, any kind of synonym of that. The smallest value. You'll need one for the lower quartile, one for the median, one for the upper quartile, and then the opposite way is then the maximum, or the biggest, or the longest, or the greatest, whatever they've used. When they give us a table as straightforward as this, we're literally just going to go and draw 5 vertical lines on these numbers. The first thing also to check out is the scale. This is quite a tricky scale because we've got 10 squares that make up 5 kilos in this case. So just be really careful of the scale. If you've got a scale that's really difficult to figure out, just do how many boxes or how many squares there are divided by the value here. So we've got 5. So what that means is we've got 2 squares or 2 boxes, however you want to call it, per kilo. So here we've got 2 kilos, right, for the minimum. So 2 times 2 squares is 4 squares. So 4 squares are long. So I'm going to draw it. I like to draw a bit shorter, but it is up to you. So I'm going to draw it there vertically in the middle of this graph. Then let's do the maximum, as that's the opposite one, isn't it? So that's at 21. So we've got to 20, but 1 kilo along would actually be 2 squares along, wouldn't it? So about there. The middle 3 are the more important pieces of information. So these 3 I'm going to draw a bit taller. You can see where I've got this thicker line here and here. I'm going to draw them that height. So the lower quartile is at 9. So 9 would be 2 squares before 10, wouldn't it? So there. The median is then at 14, which again is another 2 squares before 15. And the upper quartile is at 17. So that is 4 squares after 15. So 1, 2, 3, 4 here. There we go. So I've drawn my 5 lines. The middle 3, as I said, are the most important ones. Those are the ones we're going to create a box with. So you're going to draw 2 horizontal lines at the top and the bottom. One there and one here. So we've created this box with this line in the middle. And then the minimum and maximum lines, sometimes you might have heard this called box and whiskers. We're going to draw lines in the middle to connect them to the box. So you should have this central box, which is made up of the 3 most important pieces of information, which are always the lower quartile, median and upper quartile. And then these 2 other bits that kind of look, I guess, a little bit like whiskers that stick out on the ends for the minimum size and the maximum. That is literally it. As long as you've got these 5 pieces of information on whatever the context is, you just draw those vertical lines and then join it up in this format. And then you've drawn a box plot. That is the answer to this question. So let's try another one. The table shows some information about the heights in centimetres of some year 10 students. Draw a box plot for this information. So again, we can look at the table. The first bit is the minimum, so that's quite easy to look at. In this case, the scale is easy because we've got 10 squares, which is 10, in this case, centimetres. So every square is just 1 centimetre, isn't it? So that's fine. So 42 is obviously 2 squares along, so that's my minimum. If I then go to look for the maximum, first of all, it's not in the table, but second of all, I've got this range. So this is where they might try to make it seem a little bit harder. They've not explicitly written down minimum, maximum, but they have given you information to help you work it out. So we know the minimum, and then you should know about what the range is. The range is the difference between the biggest and the smallest numbers. So in this case, minimum and maximum. So I know that the maximum, take away the minimum, should give me 44, the range, right? Now the minimum is 142. So you could almost imagine it as an algebraic equation. How do I then work out the maximum? How do I go backwards? Well, obviously the maximum is going to be the minimum plus the range, isn't it? Plus the difference. So we should get 186. So that's our maximum. You might have to work that out. It just depends on the question. So 186, that's 6 squares along from 180. So we've got our minimums and our maximums. You can also go and tick them off if you feel like that would be helpful. So we've done those 2. Now the middle 3 are the most important as well. You can see here we've got interquartile range, median and upper quartile. So the median and the upper quartile are still there, but the interquartile range is different. So again, they're relying on us knowing what we mean by interquartile range. Well, obviously it's still some kind of range, right? Some kind of difference. Interquartile means the difference between the upper and the lower quartiles. So the interquartile range is the upper quartile minus the lower quartile, just generally. Now, we know that the interquartile range is 13. We know the upper quartile in this case is 171. We don't know the lower quartile, but obviously we'll need it for one of our vertical lines. So again, do you see how I could just reverse that equation? The lower quartile is obviously the upper quartile minus the interquartile range. In this case, minus because we were given the bigger one, we want to work out the smaller one. And that gives me 158 centimeters. So I now know the lower quartile is 158, so I'm going to draw a much taller line there. Okay, now I can tick off interquartile range, I've dealt with that. The median is just as it is, so that's at 162, so here. And finally, we need the upper quartile, which is at 171, so here. So we've got our 5 vertical lines again. Now, once you get to this point, again, just join it up. So the 3 in the middle should create a box, and then the 2 on the outside should create these kind of whisker things. There we are, perfect. So we've done it again, we've drawn another box plot. This one, again, was a little bit harder because we had to work out a few things, so don't be surprised if you do come across that scenario. Okay, so the next question is actually quite a common one, but it's a worded answer. And a lot of people don't really know, in terms of maths questions, how to explain a worded answer, so this is a really good one to memorize. So, the minutes that a bus was delayed by on Wednesday and Thursday are drawn on box plots. Compare the distribution of the delays on Wednesday with the delays on Thursday. So effectively it's a question where you've got 2 box plots. You might have had to draw the first box plot as part A, for example, and part B is then compare them. And it's normally 2 marks, compare the distribution. So you might think, well, I've literally got no idea. What do you mean compare the distribution? In this question, you're always going to mention 2 things. First of all, compare. We don't have to explain. Okay, you don't have to explain why or what it means. You just have to state the obvious, literally make comparisons. But the distribution, there are 2 things we want to comment on. The first thing is always the median. Now, if you remember to when we were plotting it, the median is always the middle vertical line, isn't it? It's the one that's inside the box. So when I compare the medians for this case, you can obviously use information like actual numbers from the box plots. That would be also helpful. Again, double check your scale so that you've got the right numbers. So here we can see obviously the median for Wednesday is 5. So you just literally say the median delay. So use the context, right? The median delay is 5 minutes on Wednesday, whereas it is, now let's check this one. This scale is quite difficult. So just double check 11, 12, 13. That'll be 13 minutes on Thursday. The other thing you can say is the median on Thursday is bigger than the median on Wednesday, for example. Or the median delay on Thursday is longer than the median delay on Wednesday. You know, any kind of thing like that. Number 2 is then more so focused on distribution as like a spread, right? I wouldn't necessarily go for the range. I think sometimes they accept that, but I would focus more on the interquartile range. Interquartile range. Now, if you remember, we've said in the previous questions, the interquartile range is the difference between the upper quartile and the lower quartile. So let's just label this. This is the median, isn't it? The upper quartile is obviously the furthest vertical line to the right on this box. So that's the upper quartile. And the lower quartile is then the lowest vertical line, but again, still within this box. So that's why I said previously that these 3 in the middle are the most important. So not only in this case do we need to figure out what the upper and lower quartiles are, I would also calculate what the actual interquartile ranges are therefore. So for Wednesday, we can see we've got, that's 11, isn't it, for the upper quartile? And then we've got, what's that? That was 5, so this is 4 for the lower quartile. So the interquartile range on Wednesday is 11 minus 4, which is 7. Thursday, you can see the upper quartile is obviously 15, and the lower quartile is obviously 10, so that's a bit easier. So the interquartile range, we minus them, gives us 5. So you can see that the interquartile range on Wednesday is larger than the interquartile range on Thursday. Okay, so if they ever ask you to compare the distribution or whatever the context is of 2 box plots, you're going to be looking at the medians and you're going to be looking at the interquartile ranges, which you might have to calculate. So use values, use data, the numbers here where you can, and just basically make a comparison. Just say one is bigger than the other, one is smaller than the other, so on. That is it for this question. It's always the same answer. So thanks for watching this video. If you found it helpful, make sure to like and subscribe. If you want to check out any of the full videos or look through more questions, they will all be linked down below in the description.